Doctrine DBAL 3.10 just got a huge performance improvement in its SQL parser. And in this video I'm going to take the time to understand it, how it works, why it works, and measure the impact for myself. Learning from performance improvements in open source libraries is a powerful way of improving one's own performance detective skills. It's also a great time to celebrate the contributors. In this case, kudos go out to Sona from Shopware. Let's look at the patch. Feature improvement performance of SQL parser. It just has a single file changed, just 20 lines added, 33 removed. The explanation for the performance improvement is merged SQL patterns into one call and call the correct one based on the regex hit. It includes a performance benchmark using the Hyperfine tool, which we also explain on our blog, running an old and a new version of a test script. The test script is attached here. We'll go into that in detail to show a factor 2 improvement for the new changes. So let's look at the diff and what it's actually doing. So in the constructor of the parser, there's additional logic being executed. So in addition to the previously available SQL pattern variable, there's now a second new one, token patterns, and it includes new regex using named arguments, or named matches. These named matches that can then be accessed directly from the pragmatch result. So what is happening in the parse function? So Sona removed a lot of code, especially an array of regular expressions, which maps to these calls here, these closures. The diff makes this a little bit hard to read, so let's switch to PHP Storm. We can see here in the old code that we are iterating over the patterns, and the patterns are again here the regex to closure calls, and then the code here iterates over that and executes those patterns against the SQL statement and performs the work if there are matches. The new code looks different, like we saw before. We are iterating over the length of the SQL string, matching the token patterns and processing them based on matches in the named and positional arguments and calling the visitor functions appropriately. This is a very clever performance improvement because it makes sure that pragmatch is only called once for a range of different patterns, and then depending on which sub-pattern is matched, only the logic for that sub-pattern is actually executed. And this is a regular performance improvement that other PHP libraries also apply. For example, JBizzle's crawler detect or the fast route PHP library from Nikita. Let's talk a little bit about the history and why Doctrine DBAL actually needs an SQL parser. When combining parameters with an SQL statement in PHP, you usually use prepared statements to safely do that. PDO has features to do this for scalar values, such as integers or strings. Doctrine DBAL improved on this by adding the feature to pass arrays of parameters to positional or named SQL placeholders. This is a powerful improvement that is used to make select where in queries with placeholders very simple, and Doctrine can just expand the placeholder to fill as many placeholders as necessary to work with an array of parameters. There have been a few iterations of this code already in Doctrine, and it improved already from version 2 to version 3 considerably. Shopware always had a performance problem with this API because they are using arrays of parameters everywhere through their code base, and the improvements from version 2 to version 3 of Doctrine DBAL already made their code much faster. With this new improvement, Shopware is getting even faster, and we are now trying to measure how much impact this change has. We are going back to the pull request and looking at the test script. I copied this test script over to my IDE, and I set up a little playground for this. I copied the code over into the new and old versions that Sonar already showed on his pull request. I'm including, based on the old version or the new version, different versions of Doctrine DBAL using Composer. I installed them using 2 subdirectories, and I improved on the SQL query here a little bit to get some understanding. The SQL statements that Sonar provided in this test script is extremely large. It contains a bunch of subqueries, joins, and especially the select clauses contain hundreds of columns being selected. A regular expression running over a string that is that long obviously can take a lot of time if implemented incorrectly. So this is why we can see these big improvements here that Sonar made with this patch. The test script is really simple. For this big query, we are running the SQL parser 2000 times, expanding the parameters here. Especially, you can see the array parameter type triggers the SQL parser to expand the parameters in this particular location here, where we have an where in query for the category IDs, and we are passing 3 IDs here. So let's run this using Hyperfine like Sonar did locally. I'm running Hyperfine with a warm-up of 1, meaning I'm calling the programs beforehand to maybe trigger some Linux caches, and then I'm running the old version against the new one. The Hyperfine now calls the program a few times. You can see that we have an estimate here of how long the script takes. 2.8 seconds we have estimated for now, and another 10 seconds of the benchmark is running. And this is running a little bit slower than when I ran this without video capturing before. So let's see if we can actually get a fairly realistic example run here, and it looks like we do. The new PHP script currently estimates at 1.2 seconds. So we have an improvement of a factor of 2.3 faster than the old .php. And if we scroll up here, we see the same range of improvement, 2.37, without the video capturing active, but it ran much faster. So this code shows that when just looking at the SQL parser, on a factor of 2.3 faster than with the old code, a massive improvement for this kind of code. The lesson that we can learn from this performance improvement, that there is a lot we can do with regular expressions if we merge patterns and use named matches to reduce the amount of regular expressions we call and to delegate based on the matches that we made, instead of like having separate regular expressions that we evaluate individually. If you want to follow along, watch this next video about PHP performance improvements, and have a nice day.